Separating mixtures. Mixtures can be separated using physical methods. There are 4 separation techniques you need to be familiar with, and these methods are filtration, evaporation, chromatography, and distillation. All 4 make use of the different properties of the constituent parts to separate them out. Let's start with filtration and evaporation, looking at the example of separation of rock salt. Rock salt, put simply, is a mixture of salt and sand. Salt and sand are both compounds, but the salt dissolves in water and the sand does not. This vital difference in their physical properties gives us a good way of separating them. Here are the 4 steps of the method. 1. Grinding. Grind up the rock salt with a pestle and mortar. 2. Dissolving. Dissolve in a beaker and stir it. 3. Filtering. Filter through filter paper in a funnel. And 4. Evaporating. Evaporate in an evaporating dish. You will get big crystals by boiling off half the water, then leaving the dish in a warm place to evaporate slowly. The sand in the rock salt does not dissolve as it is insoluble, so it will stay as big grains. When you filter the mixture, the sand will not fit through the small holes in the filter paper, so it will collect on the filter paper. The salt is dissolved in solution, so it does go through the filter paper. You can boil the solution you are left with to evaporate off the water. The liquid water will turn into water vapor and escape, and when the water's evaporated, the salt forms as crystals in the evaporating dish. This is called crystallization. Now let's move on to chromatography. Chromatography is ideal for separating dyes in inks. Chromatography uses a solvent soaking through chromatography paper to separate the dyes, and the different dyes will travel along the paper at different speeds. Some will stick to the paper, and others will dissolve into the solvent and travel through it quickly. You can also analyze substances using chromatography. Chromatography isn't just a great way of separating dyes. A chromatogram, which is a pattern of spots or rings left behind, can tell you a lot of information about inks and other mixtures. The more soluble the dye, the more it travels. How far a dye travels depends on how soluble it is in the solvent. Dyes that are soluble get dissolved in the solvent and transported a long way. If a dye is soluble, it will not move at all. Chromatography can also be used to investigate blood samples and chlorophyll. Moving on to distillation, simply distillation separates pure water from ink. Simple distillation can be used for separating out a mixture of a liquid and a solid. The liquid is heated and evaporates off to form a gas. The gas is then cooled and condensed back into a liquid inside a condenser. The liquid is then collected, leaving the solid behind. Simple distillation is a great way of separating pure water from ink, or for getting pure water from something like seawater or suspect tap water. Fractional distillation separates mixed liquids. It is used for separating a mixture of liquids like crude oil. Different liquids will evaporate off at different temperatures, around their own boiling point. The fractioning column ensures that the wrong liquid condenses back down and only the right liquid properly boiling at the temperature on the thermometer will make it to the top. When each liquid has boiled off, the temperature reading rises until the next fraction starts to boil off. Some real-life examples of fractional distillation include distilling whiskey, separating crude oil into petrol and diesel, and other fuels. You can check the purity with melting and boiling points. A pure chemical substance fixed melting and boiling points. For example, pure water's boiling point is 100 degrees Celsius, and pure ice melts at 0 degrees Celsius. This assists us with identifying unknown substances, like if a liquid boils exactly at 100 degrees Celsius, it is likely to be pure water. Impurities change the melting and boiling points of substances. Impurities in water can cause it to boil above 100 degrees Celsius. It means you can test the purity of a substance you have separated from a mixture by boiling or melting it.